A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of two school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the two sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soiled bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between two tectonic plates, the Somali plate in the east and the Nubian plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali plate could split completely from the Nubian plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this sixth ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift System. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift System. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift System's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
Our planet has 5 oceans: the Pacific, Atlantic, Indian, Southern, and Arctic, not counting Billy Ocean. But it seems there's a 6th one out there too. It's just that you can't see it. Scientists have found evidence of large amounts of water hidden in the transition zone. That's the boundary layer that separates the upper and lower mantle of our planet. That boundary goes hundreds of miles deep down below the surface. Natural diamonds usually form in the mantle, but at depths of up to 155 miles. Some of them are very rare. They may come from deeper depths. That was the case with this fascinating diamond that formed 410 miles below the surface. The gem was big enough for scientists to study it and determine what it was made of. They were surprised when the composition of this very rare diamond showed that it was formed in pretty watery conditions. Because of that, such a diamond wouldn't be worth much in jewelry stores, but it was priceless in the lab. So, could this mean there's an ocean under the surface of our planet? It would definitely get us closer to the idea Jules Verne had about this whole magical secret world inside Earth, including the ocean. But that's not exactly the case. The water is there, true, But it's not like you can enjoy the view watching waves splashing around like on the surface of our planet. The water is actually stored within the minerals. That's why this area is so wet. Let's now move to Africa to keep up with the story, or to be more specific, to a spot called the Afar region. It's part of Ethiopia and a place where three tectonic plates meet. Tectonic plates are large pieces of our planet's crust that slowly move. These movements cause earthquakes and produce volcanoes, mountains, deep underwater valleys we call trenches, and so on. And the Afar Valley is where the Arabian, Somali, and Nubian plates meet. Together, they form an intersection in the shape of a Y. Why? Let me tell you. These plates are moving all the time. The Somali plate is moving southeast toward the Australian and Indian plates. The Arabian plate is moving north, getting closer to the Eurasian plate. At some point, it will close the Persian Gulf. This movement of plates has created something we call the Great Rift Valley, considering there are, all these cool rifts. The Aden Ridge to the east, the Red Sea Rift to the west, the Oculus Rift and the East African Rift to the south. But the East African Rift is something we want to focus on, because this one could be the key to this potential sixth ocean, but this time on the surface. A continental rift is a spot where two tectonic plates that form a single continent start to separate. Here it's the Somali and Nubian plates. Together, they're parts that make up Africa. If they keep moving in separate directions, this currently continental rift may become what we call an oceanic spreading ridge. In other words, when the plates are far enough apart from each other, there will be an enormous crack between them. This way, magma will freely flow up from beneath them. It'll be cool and eventually start creating a new ocean floor. Africa will be split into two parts, and there will be a new ocean flowing between what will turn into two mini-continents. Nope, it's not time to get your swim trunks and sunscreen yet. Even if the Somali and Arabian plates do move far enough to form an oceanic spreading ridge, it'll take millions of years before this happens. So I guess it's more interesting to stick to exploring this sixth ocean below the Earth's surface for now. The idea of subsurface oceans goes beyond the borders of our planet. It's possible many moons and planets out there have them too. Our home planet is the only one we know about with consistent bodies of liquid water on the surface, true. In our solar system, we circle around the Sun in something called the habitable zone. The temperature and atmospheric pressure within this zone allow water to remain in liquid form all the time. But a couple of moons in our solar system could also contain significant amounts of water under their surface. Enceladus, one of Saturn's moons, is the first one. Enceladus is a small frozen ball 7 times smaller in diameter than our moon, but it's the 6th biggest moon of Saturn. Nearly a decade ago, a spacecraft found evidence that there was a large ocean under its surface. It found and sampled water from the eruptions that resembled geysers. A geyser is a rare type of hot spring that erupts and sends jets of steam and water into the air. Like Old Faithful in Yellowstone? Well, this water was erupting through fissures in the ice at the south pole of the moon. That means there might be a liquid ocean under the thick layers of ice. The ocean there is almost nothing like ours. The ocean on Earth is relatively shallow, on average 2.2 miles deep, and it covers 3/4 of our planet's surface. It gets colder the closer you come to the seafloor, and is warmer if you stay close to the surface because of the sun's rays. But the subsurface ocean on Enceladus is at least 18 miles deep. It's cooler at the top because that part is near the ice shell, and warmer at the bottom because of the heat coming from the moon's core. But both our ocean and the ocean on Enceladus are salty. Enceladus is one of the few places in our solar system that has liquid water, which makes it an interesting spot to search for signs of life. Another one is Europa, one of Jupiter's moons. Scientists think similar eruptions of water could be happening there. Knowing there are such geysers there tells us these moons have their own source of energy. Maybe the energy that makes the water erupt comes from gravity or radiation. The same energy could keep a large body of liquid water under the ice. It could even support some forms of life. There are thousands of planets beyond our solar system that orbit other stars. Some are even in the habitable zone. Over a quarter of the ones that we know about could have liquid water, but the majority of them probably have oceans under their surface, like Enceladus and Europa. Pluto might be on this list too, since it's possible it hides a liquid ocean under its thick frozen shell. This subsurface ocean likely formed long after the dwarf planet did, after the heat coming from radioactive elements in Pluto's core melted some of its ice. There's also something called water worlds. Those are moons or planets with global oceans that are more common than we thought. I mean, some call Earth a water world too. 71% of its surface is water after all. And when you look at our home planet from space, you mostly get those blue marble pictures. When exploring other planets, especially those outside of our solar system, researchers often go with a policy of follow the water. After all, water is the main element we know that's necessary for supporting life. And when there's a water world that's close to its parent star, scientists assume it must have formed way farther and then moved closer once its orbit shrank. The composition of the planet was set when it was in a colder orbit, or, in other words, when it made a wider circle around its star. We call the process of orbital shrinking a migration, and if water worlds are really that common, it can be proof that migration really happens. Exoplanets are all those planets that orbit around other stars, not our Sun. Some exoplanets may have oceans that are way deeper than any of those in our solar system, hundreds or even thousands of miles deep. Our Mariana Trench is scary, and it's not even 7 miles deep. And those exoplanet oceans are, wow, almost bottomless. Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So, let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widen into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands, or small continents. The news isn't great for Madagascar either, as the world's 4th largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a 6th ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago.
Imagine there is a huge crevice right under your house. What would you do? Probably pick up your belongings and evacuate the structure. This is what happened to one Kenyan back in 2018. A massive crevice formed almost overnight under his home. The man escaped to safety, but the event revealed a deeper issue. Much deeper than most people thought. The crevice appeared after a month of heavy rainfall. This part of the country, west of the Kenyan capital of Nairobi, sits in a seismically active region. The massive hole in the ground was covered with ash from a nearby dormant volcano. The crevice in the ground ran for miles, and it was 65 feet wide in some places. It was as deep as the Hollywood sign is tall. The gaping hole damaged a vital local road. People soon dubbed it the Grand Canyon. But this is no laughing matter. The same thing happened in 2023. Kenya's highway authority had to close the busy road for repairs once again. Preliminary reports showed that heavy rains were the likeliest cause. The rupture itself is part of the Great Rift Valley. It extends from Jordan in the north to Mozambique in eastern Africa. Its total length is nearly 1.5 times the distance from New York to Los Angeles. Rift valleys are located all over the planet. They're lowland places where tectonic plates move apart or rift. These are huge slabs of rock in Earth's outermost layer. They rest on molten rock underneath, which makes them unstable. Tectonic plates are constantly on the move. They can bump into each other, or one plate can go under another. This can occur both on land and at the bottom of the ocean. Continental rifts are less frequent than the ones we find underwater. The East African Rift is one of 4 major ones. The nearby Arabian Plate has been on the move for the last 30 million years. When it separated from the African mainland, it created the Red Sea and the Gulf of Aden. When you look at the physical map of Africa, it looks like one contiguous landmass. But when you dig deeper, quite literally, you realize it rests on 2 tectonic plates. The Nubian one carries most of the continent. The smaller Somali Plate holds the Horn of Africa. The crevice in Kenya appeared in the Rift Valley between these 2 plates. That's because they're moving away from each other. The rift is growing larger, which means that one day the African continent will split into 2. The rifting process is a slow one. The present rate is just 1/4 of an inch every year. Scientists estimate that the split will occur in 5 to 10 million years. Some experts place this event 50 million years into the future. The end result will be 2 African subcontinents. They will be separated by a body of water that will become our planet's 6th ocean. This also means that 5 now landlocked countries will get access to the sea. When they get a coastline, the countries could build harbors to trade with the rest of the world. 3 other countries, including Kenya, would find themselves on 2 continents. The future split of Africa into 2 parts might sound dramatic at first, but it wouldn't be unnatural. This is the first time, after hundreds of millions of years, that the shape of Earth would change so much. The last time this happened was during the Jurassic period. If you're now thinking of Steven Spielberg's 1993 blockbuster movie, you're right. the world of dinosaurs had a different shape than the one we're familiar with today. There was a supercontinent called Gondwana. It included today's South America, Antarctica, India, Africa, Arabia, Madagascar, and Australia. Then, around 180 million years ago, things started to change. Earth was starting to take its familiar shape. The Indian subcontinent collided with the Asian mainland. The event gave rise to the Himalayan mountain range. These are the highest mountains in the world, with 30 peaks over 24,000 feet in altitude. This process is far from over. The Himalayas are still growing in height. On the other side of Gondwana, Africa and South America first separated together. But they weren't meant to last long. 40 million years later, South America started drifting away from Africa. This created the South Atlantic Ocean. The evidence of this ancient continental drift is obvious to this day. If you look at the map of South America, you'll notice a bulge in its eastern part. That's the modern country of Brazil. On the other side of the Atlantic, Africa has a huge inland curve on its western side. The two act as pieces of a giant jigsaw puzzle. They roughly fit into one another. European scientists noticed this as early as the 17th century. Further research confirmed the theory that South America and Africa once belonged to the same landmass. This is only one part of the story. At the beginning of the 20th century, a German scientist came up with the theory of continental drift. He believed that all of Earth's continents were once part of a supercontinent called Pangaea. The name comes from Greek, and it means all of the Earth. Makes sense, doesn't it? It was surrounded by the oceanic ancestor of the Pacific Ocean. Some 200 million years ago, this gigantic landmass was home to many animal and plant species. Thanks to them, scientists could piece together what our planet used to look like. For example, Mesosaurus was a giant freshwater reptile that existed during the Cretaceous period. Paleontologists found its fossils in only two places, Africa and South America. The animal lived in fresh water, so there was no way it could have swam in the Atlantic Ocean. This pointed to the fact that it lived in a single habitat, rich in rivers and lakes. This would have been possible in only one scenario. The two continents that are now miles apart were once a single piece of land. Pangaea wasn't the only supercontinent in Earth's history. Continents came together and drifted apart several times throughout our planet's past. Researchers know of at least 3 times this happened. Pannonia formed 600 million years ago. Rodinia was an even older supercontinent. It existed 1 billion years ago. The driving force behind all these changes was tectonic activity. Plates deep beneath our feet have the ability to create new land and oceans. This is what's happening in East Africa right now. This activity is most evident at the bottom of the sea. Molten rock rises from deep within the earth to create new seafloor. The process is called seafloor spreading. It happens along underwater mountains called ridges. One example is the Mid-Atlantic Ridge. I think you can fairly accurately guess its location. Over time, the seafloor grows wider here. This has an effect on the continents on both sides of the ridge. Seafloor spreading causes continents to move away from each other. Right now, North America is moving away from Europe at a rate of 1 inch per year. This doesn't seem like much, but give it 50 million years and the Americas are gonna bump into the western part of Asia. The two landmasses will form a new supercontinent. Geologists from Yale University have a name for this land, Amasia. Talk about rushing before the ore. They ran a series of computer simulations to see what Earth would look like millions of years from now. The new continent is likely going to form somewhere around the North Pole. But don't go shopping for winter clothes just yet. The time frame for this event might extend to 200 million years into the future.
Mirror check. You've got your beige parka on, your chisel is packed, and your overnight plane ride to Saudi Arabia is booked. You know what this means, right? Unfortunately, you weren't cast in the remake of Dune. It just means that you're ready to go explore the world's largest desert areas in the hopes of uncovering prehistoric secrets about our ancestors. Let's get one thing straight. If you ever thought that deserts were empty spaces, think again. They might be filled with sand as far as the eye can see, but they also hold a lot of history, you know, because before humans settled down in cities and towns, we were nomadic people, and we traveled all around the globe looking for food, water, and shelter. So we had to come up with some interesting stuff to survive. Like this thing that was found in the desert of Saudi Arabia. Do you have any idea what this could have been? Over many years, scientists have discussed the origins and use of huge structures such as these ones. It seems our Neolithic ancestors were way smarter than we gave them credit for. They didn't spend all their hours around the fire carving weapons out of stone. No, they were also practicing their architectural skills. These huge stone structures are called desert kites, because if you look at them from a distance, well, they sort of look like kites. Archaeologists have arrived at the consensus that these kites were used to lure animals in. This way, it would make it easier for our ancestors to guarantee their week's food. But that's not all. Take a look at these monolithic structures right here. They show us that our ancestors probably drew on rocks, the blueprint of what they were going to build on the ground. Just like modern-day architects, desert kites could be miles long, so they drew out a plan before actually building them. The most surprising feature of all is that these kites were built even before things such as Stonehenge. We're talking around 7,000 to 9,000 years ago. Over the last decade, scientists have been able to identify over 6,000 desert kites spread across the Middle East and West and Central Asia. If you don't think this huge, try building something this large without the help of any drones. It looks like a pretty difficult feat to me. And apparently, Saudi Arabia's desert is filled with more amazing things. Scientists have found mysterious stone structures that are older than the pyramids of Giza in Egypt. So of course, you can't wait to go check that out. Can we all agree that carrying around heavy rocks to build a pyramid without the help of modern technology sounds absurd? I mean, how on earth did they do it? Now imagine turning back the clock about 2,000 years into the past and finding humans that built similar gigantic structures in isolated areas. Take a look at these so-called mustadils. They are rectangular structures built from piled-up stones, found over 77,000 square miles. Some archaeologists believe that these monuments were used for ritualistic purposes, maybe processions of some kind, where people would walk from one end of the plateau to the other. I'd be down for that. Now let's move on to another deserted area. We're entering the world-famous Sahara Desert landscape. Isn't it beautiful? Here, you're about to unravel an ancient mystery, something that took years for researchers to solve. Fun fact, the Sahara Desert is the world's largest hot desert. It spans over 3 million square miles, which would be like putting 1,000 times the country of Hawaii next to each other. We say it's the largest hot desert because the world's largest desert area is Antarctica. But we all know temperatures over there are freezing, not the typical image of when we think of a desert. Deep into the desert, near the Algerian town of Fougeret et Zoua, something strange was found. For decades, these tiny dots appeared on images of Google Earth, but nobody could explain what they were. Some scientists were sure that these circles are the result of oil activity in the region. Others guessed that these were ancient fogeras or ancient water wells. There are dozens of them, stretching for miles and miles in a straight line. The strange thing is that they are always far away from any town, road, or human activity in general. So what was or is their purpose? If you had to take a guess, what would you say? Remember we talked about how our ancestors had to be creative in order to survive in the desert? Let's try to walk in their shoes for a minute. Imagine you're a nomadic hunter-gatherer living in a desert area. You spend your days basking in the hot sun, trying to count all the grains of sand around you. But you also need to eat and drink water. But how on earth do you get water in a desert? Sure, you can hope to keep running into oasis every week or so, but that seems a bit risky, doesn't it? That's why North African people invented the so-called fogeras. The fogeras are a 2,500-year-old irrigation system. Locals would dig deep wells in elevated areas, wells deep enough to tap into underground water. Then, they would dig parallel shafts at regular distances. This way, the water would flow from the main well down into all the shafts and irrigate entire areas. Travelers could stop by the shafts and quench their thirst. They could also raise livestock and tend to crops. Pretty clever, huh? As much as these holes did look like fogaras, a little bit of research would show you that they're not. You see, these shafts were built in a line, and not in a circular shape like the ones we're looking at now. So maybe it has something to do with the second option? Maybe these desert holes were related to oil activity in the region? Let's have a look at the holes up close and personal. From Google Earth, they don't seem that big, but in real life, they are huge craters. The tip to uncovering what they are is hidden beneath the sand. If you were one of the researchers originally uncovering the truth behind this mystery, you would have found something unique hidden in the sand. Old dynamites and vintage sardine cans. Putting the pieces of the puzzle together, scientists found that these sardine cans were a model from the 1950s and 1960s. It seems that entire teams from that decade would camp out while they surveyed the area for oil. And what about the dynamites? These were used for seismic surveying. This is an old technique, used to identify if there is oil and gas beneath the Earth's surface. Still in North Africa, you find out about another desert mystery worth exploring. Near the city of Tiaret, southwest of Algeria's capital, one runs into 13 peculiar monuments. These structures are also called jedars, and yes, I am aware of how much that may sound like a Star Wars reference. They are pyramid-like in their shapes, and as far as scientists know, they were used as final resting places for the people who lived in the region. Can you guess who these were? Most likely the Berber nomads. And since we're talking about ancient stuff, they were probably built between the 4th and 7th centuries CE. Once scientists began to explore the insides of these monuments, they found they were pretty big inside. They found large underground vaults, chambers, and labyrinth-like corridors that gave way to over 20 compartments. It could take you up to 2 hours to walk around in them, and apparently our ancestors also used its walls to depict images of animals and hunting scenes. There's no definite proof of what these jedars were used for, though. This is so neat, huh? I'm sure that our world's desert is filled with many more mysterious things for us to unravel. I guess I'll see you next time so that we can continue our...
India could split horizontally into two parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely 1/10 of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept: the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where 2 or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya. First in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into 2 subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The two are gradually moving away from one another, which causes the formation of crevices within the rift valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into two continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today.
Phew! This summer has been turning up the heat like never before. We feel like roasted marshmallows on a sizzling grill. Yes, the world is getting hotter, but some regions have always fought with high temperatures. It turns out people had some inventions to keep themselves cool in ancient times too. Some of them are still functioning, even 3,000 years later. Let's take a look at how people saved themselves from heat throughout history. So, put an ice cube into your cold drink and get ready to hear how people survived the heat. Speaking of ice cubes, do you know that the Persians made an ice storage system? In the deserts of ancient Persia, people had an out-of-the-box idea about how to prevent their food from turning into a melted mess. These ingenious Persians stumbled upon a physics trick that allowed them to create ice in the middle of the desert. They called these cool structures yakhchals, which basically means ice pits. These ice pits were not your ordinary coolers. They were like secret underground fridges. They looked like dome-shaped mud brick structures on the outside, but inside, it was a whole different world. These ice pits had an evaporation cooler system that worked like magic. At night, when the desert cooled down, Persians made use of the radiative cooling effect. They set up cleverly designed trenches to hold thin layers of water. The water froze, defying the desert heat. Then there were underground square storage areas. The Persians collected the melting ice water from these cool trenches, and during the night, they froze it again, making the most of the desert's natural chill. To add to the cooling effect, they built a wall to shade the storage areas from the hot midday sun. And that's not all. They had this fantastic wind-catching contraption called a badger that caught the breeze and directed it right into the ice pits. Fresh air plus ice. Cool breeze. A winning combo. They even had intricate water channels called qanats to bring water to the ice pits and homes all the way from the nearby mountains. As time passed, these yakhchals faded into history and modern technology took over. But hey, there's good news too. Some awesome folks in Iran are restoring these ancient coolers. So, if you ever find yourself in the desert, don't forget to pay a visit to these marvelous places and witness the genius of the ancient Persians firsthand. Now, I want to focus more on the wind catchers because they don't just help make ice cubes. They actually function as a cooling system as well. Back in the day, those clever architectural wonders were all the rage in places like Persia, modern-day Iran, Egypt, and the Middle East. Imagine tower-like structures with openings at various levels strategically placed to harness the power of nature's breeze. These openings were like magical portals for the wind. They captured those refreshing gusts and guided them right into people's living spaces. Basically, they were natural air conditioners. The breeze would gracefully flow downward, cooling the ground as it danced through the building. The secret sauce lies in the details: the tower's height, the number of sides, the openings, and the positioning of the interior blades. Everything plays its role in how efficiently the wind towers work out. Thanks to these wind catchers, ancient societies could enjoy comfy indoor temperatures without sweating. Can you imagine living in those times? Feeling the gentle breeze whisking through your home, keeping you feeling fresh and chilled out? The Persians are often credited for inventing these awesome wind catchers. But hey, don't forget about Egypt. There, you can find traces of similar structures dating all the way back to 1300 BCE. Yes, the invention of wind catchers may have occurred in ancient Egypt, but Yazid in Iran is the city with the largest number of wind catchers. People wouldn't have been able to live there without these ancient ACs, because there was almost no rain in the area throughout the year. Now, let's look at these perforated double-skinned exteriors. Imagine dressing up a building with a fancy perforated screen. It's like giving its exterior a stylish makeover while keeping things chill inside. This genius technique, firstly, scatters the natural daylight, so no harsh sunbeams to blind you. The screen also offers shade like a pro, giving the building's interior a much-needed break from the blazing sun. Think of it as a natural sun hat for your home. Placing this screen about 4 feet away from the outer walls creates a breezy, dreamy hallway for fresh air circulation. And hey, they add a touch of elegance to the building too. These structures are sometimes called jali. Jaipur, India, for example, has an average daytime temperature of about 100 degrees Fahrenheit. So these structures are lifesavers. Jalis come in various forms, crafted from cement, earth, and wood. It's a cultural symbol deeply embedded in Indian architecture. You can find its captivating presence in iconic historical buildings like the majestic Taj Mahal and the Grand Red Fort in Delhi. But hey, it's not just a thing of the past. It's still rocking modern architecture scenes, and its charm has sparked creativity in artists and designers worldwide. It adorns the building's exterior, its cross-section showing a larger opening on the outside and a smaller one on the inside. This is where the Venturi effect steps in to show off its physics prowess. As the air flows through the narrowing passage, it picks up speed, creating a difference in pressure between the inside and outside of the building. Air blowing at a higher speed gets compressed, and when released, it cools down. Mashrabia is a wooden lattice or screen used in the Middle East and North Africa. These decorative wonders are like window blinds, but they do more than just look pretty. They're smart too. They give privacy, shading you from the sun, and let fresh air and light in. Some people also add clay pots filled with water, sand, or damp straw to their designs. As hot air breezes through the holes, it also passes through the pot's porous surface. The moisture inside evaporates, cooling the air. This is a perfect low-cost technique for hot and dry climates. It's eco-friendly, and there's no need for electricity. Now, let's fast forward to today. Designers are getting creative, mixing traditional wisdom with modern tech. At the Al Bahar Towers in Abu Dhabi, they've got it too. Picture over 2,000 hexagonal panels that dance with the sun's movement, providing shade to the building's interior. Water evaporation was another secret weapon for ancient people. Simple, yet super effective. Plus, ancient Egyptians hung wet mats and curtains in doorways. When the air passed through them, it cooled down, providing a relief from the scorching sun. Ancient architects were the masters of maximizing airflow. They knew how to cross-ventilate and let hot air escape while inviting cooler air to the party. Speaking of ancient Rome, bathhouses were the place to be back then. It was like a community hub. People gathered to chat about politics, play sports, and, of course, take a relaxing dip. The frigidarium was the cool spot in Roman baths. After a steamy soak in the caldarium, Romans dashed to this giant pool to chill out. Then in some places, like Cappadocia in Turkey, people went underground to hide from the heat. They carved cozy dwellings in volcanic rock, harnessing the Earth's natural cooling powers. So the lesson here is simple. Architects and designers can create wonders by combining local traditions with smart tech. California's Death Valley boasts the highest officially registered temperature to date, with 134 degrees Fahrenheit in 1913. Meanwhile, Africa's sweltering record stands at 131 degrees Fahrenheit in Kebili, Tunisia, as noted in 1931. In Europe, the highest temperature ever documented reached almost 120 degrees Fahrenheit in Sicily in August 2021. Then, in 2022, the UK had the hottest summer of all time.
In 2018, the most powerful underwater earthquake occurred between East Africa and Madagascar. There was a deep rift between the Earth's crust and the mantle. Hundreds of thousands of tons of magma came out on the surface of the ocean floor. After that, a huge underwater volcano with a height of 2,700 feet was formed near the coast of Madagascar. This is almost twice the height of the Empire State Building, and all this is hidden under the water. French scientists studied this place since it had regular seismic activity. When the geologists went on an expedition to the coast of Madagascar, they discovered this giant underwater rock, which was not here until recently. With the help of geological equipment, they discovered the earthquake happened deeper than usual, below the Earth's crust. Geologists created a special observatory to monitor the situation at this site in real time. Between February and May 2019, they recorded about 17,000 seismic activities below the ocean floor. Scientists had never recorded such deep earthquakes. This suggests that there are reservoirs and drainage systems inside our planet through which magma flows. It's like the veins and vessels of a living organism. The volume of lava the volcano spews at this place can be compared with the volcanic eruptions in the hottest spots of Earth. Perhaps this is one of the most catastrophic, but at the same time, beautiful events in nature over the past few years. To understand what can be beautiful about this, let's first figure out what an underwater volcano is and how it works. Inside our planet, there are incandescent liquid metals and molten rocks containing almost all the chemical elements from the periodic table. All this hot substance is called magma, which constantly flows in the planet's bowels. Anyway, magma is lighter than the surrounding Earth's crust, so it always tries to break out upwards. Fortunately, the surface of our planet is strong enough and doesn't allow magma to splash out. But sometimes it happens, and here's why. The Earth's crust consists of many solid parts, tectonic plates. These plates collide with each other because of movement. Imagine a massive picture of puzzles. Each detail of this puzzle is a tectonic plate, and they all are constantly moving. Sometimes one puzzle gets unhooked from another. When this happens, magma immediately spills out of the resulting gap. And these places of faults with flowing magma we call volcanoes. When such a volcano erupts, a new geology begins. A splash of magma shakes the ocean floor. Lava and ash erupt from the inside of our planet. It causes a release of destructive energy of incredible power. But thanks to the water, such a catastrophe can go unnoticed. More than 70% of the seismic activity associated with volcanoes occurs underwater, and almost no one notices it. But inside the water, there's a total mess. Lava heats the water and destroys the seabed. The ocean in this area boils, and large air bubbles rise up. But the enormous pressure of hundreds of millions of gallons of water suppresses the volcano's destructive power. Molten rocks of the Earth's crust are pressed against the seabed. The ocean blocks the consequences of the disaster, but sometimes the eruption gets to the surface. Such a case occurred in 2012. Vast pieces of pumice, the size of a van, began to float up in the southeastern Pacific Ocean. There were hundreds, even thousands of them. It was more like a group of unknown islands. Volcanic rocks scattered in the ocean over an area twice as large as New Zealand. Scientists use deep-sea sonar apparatus on the remote control to determine the full scale of the disaster. They studied the seabed for a long time and found 14 craters that released lava. The researchers saw that more than a third of the erupted volcanic material surfaced and scattered throughout the ocean. The rest was scattered along the bottom. It destroyed all marine life in the area. However, after the eruption of volcanoes, life is reborn like a phoenix from the ashes. Volcanic ash, lava, and soil around the volcano contain many useful elements and minerals. They nourish the soil and promote the development of microorganisms not only on land but also in water. That's why there's so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form natural islands. This is a long process, resulting from which a large piece of land comes out of the water. When magma goes out, the water immediately presses it to the seabed. The eruption can go on for a long time. The released magma raises the level of the seabed. After another 100, maybe 1,000 years, a new eruption begins. New magma flows lay a new layer on the surface of the previous one. Over millions of years, layer by layer, the volcano has been growing. It's slowly rising up because of constant eruptions. Some volcanoes may go out forever, and some continue to erupt. And then, one day, the level of volcanic rock reaches the surface in the form of a huge island. After many more years, the volcano may go out, and then life appears on the formed island. The destroyed seabed area is filled with animals, trees, flowers, and plants. These volcanic islands have unique ecosystems because they develop separately from all continents. Observing such islands helps scientists understand how life on Earth was born. There are hundreds of islands around the world that have appeared because of eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, and Iceland. Many of them are inhabited by people. They build villages and small towns there. The ground on such islands is fertile. Fruits and vegetables grow there. The water is filled with fish. Such places may seem like paradise, but at the same time, it's dangerous to live there because the volcano may wake up. One of the most famous eruptions occurred on the island of Ogashima, south of Tokyo. People built a beautiful city right in the crater of an active volcano, and in May 1785, the eruption began. No one expected this to happen. At some point, thousands of birds rose and flew away from the island, and then the ground began to shake. A heavy, low sound came from beneath the underground depths. Thick smoke escaped from the top of the green volcano. The mountain threw dirt, large rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People managed to evacuate, and then there was a long recovery. Locals rebuilt the houses and brought the city back. Almost 250 years have passed since that moment, and during this time, the volcano has never woken up. Despite the risk of a new eruption, people continue to live there. The population is growing since this place resembles paradise, and no one wants to leave it. There are thermal springs, dense jungles with rich soil, and many fish. Meteorological and seismological services constantly monitor the volcano's activity. Movements and fractures of tectonic plates create another natural disaster, destructive tsunamis. Unlike volcanoes, huge waves are formed when seismic activity causes the crust to move vertically, up or down. When this happens, water pressure shifts on the ocean floor, which releases energy. This energy pushes the water and creates a tsunami. By the same principle, you form a small wave when you throw a stone into the water. First, a small tsunami appears. Then it picks up speed and increases in size. Its height can reach the level of a 5-story building. It's heading for the coast and accelerating to 500 miles per hour. This is almost twice as fast as a Formula One race car. Millions of gallons of water, weighing thousands of tons, are getting closer. And now, the wave reaches the shore and demolishes everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. Such tsunamis are a frequent occurrence on the coast of Japan. People have built massive shields near the land to stop the waves before they hit the shore. Still, in spite of all preparedness, somehow, nature always prevails. Trace your finger around the very bottom of the African continent like this. Seems like a simple task, right? But in real life, out on the ocean, it's basically the nautical version of entering hard mode in a game. Except you can't rage quit. Every sailor who's ever faced it knew they were in for a storm buffet, unpredictable currents, and a constant sense that the ocean was out to get them. The legendary Cape of Good Hope has a misleadingly cheerful name and a way less cheerful reputation. The story starts back in 1488 with Portuguese explorer Bartholomew Dias. He was the first European to make it around the tip of Africa. When he saw the terrifying storms tossing his ships, he named it the Cape of Storms. But his king, John II of Portugal, decided to rebrand it to the sunnier Cape of Good Hope. Yeah, he wanted to promote it as an optimistic route for merchants and explorers. Plus, the discovery was a good omen that ships from Europe could reach India by sea. But the sailors who actually had to steer through it soon lost all the optimism the name promised. The Cape sits where the Atlantic Ocean and Indian Ocean meet, violently, and the winds there are brutal. They don't just blow in one direction, they flip around, like the world's worst fan setting. In the southern hemisphere winter, June to August, cold fronts from the Atlantic blast through with violent storms. Add some rain, fog, huge waves, or all of the above. If you were a sailor back then, your odds of survival felt closer to winning a chest of gold in some 16th century lottery than actually getting through in one piece. And then there are the currents. The cold Benguela current from the Atlantic slams into the warm Agulhas current from the Indian Ocean. Instead of blending nicely, like a smoothie, they churn up massive chaos and produce rogue waves that can rise higher than a 10-story building. Sailors describe them as walls of water that just show up to ruin your day. With modern equipment, you can survive if you meet them, or better, avoid them. But back in the 1500s, when your technology was a wooden ship and a prayer, one rogue wave could wipe out your entire voyage. And as if the Cape of Good Hope wasn't enough drama, a few miles east, there's the even nastier Cape Agulhas. This spot is the southernmost point of Africa, where the Atlantic and Indian Oceans officially meet. Cape Agulhas has shallow waters with reefs, hidden rocks, and sneaky sandbars that shift around. For centuries, sailors called it a ship graveyard. Historians have counted hundreds of wrecks here, including ships loaded with gold, porcelain, and spices that never reached Europe. The bones of ships still lie under those waves, like a giant warning sign saying, "Don't even try it." Now, if we zoom out to show the broader history, the stats are brutal. Between the 15th and 18th centuries, during the Age of Sail, so many ships sank here that European traders treated the Cape like a terrifying game of odds. You could make a fortune bringing back silk, spices, and jewels from Asia, or you could vanish into the ocean. That's why sailors passed down horror stories like campfire tales, ghost ships haunting the Cape, cursed waters, and there was also the famous legend of the Flying Dutchman, doomed to sail around the Cape forever. Navigating all this before GPS, satellites, or weather forecasts in a creaky wooden ship with no compass and some half-reliable maps was almost impossible. With no ports nearby to duck into for shelter, the sailors were all alone out there, sort of like playing hide-and-seek in a thunderstorm while blindfolded. Historians note that many of these brave folks regularly got blown off course or smashed into rocks they didn't even know existed. So, eventually, someone came up with a better idea. Let's dig a shortcut. In 1869, the Suez Canal opened in Egypt. It connected the Mediterranean to the Red Sea. Ships traveling between Europe and Asia didn't have to play the Cape's stormy lottery anymore. Using the canal reduced the voyage from the Arabian Sea to London by some 5,500 miles. Today, the canal handles 12 to 15% of global trade. That means millions of containers, tankers, and cargo ships take the safe shortcut instead of risking the so-called Cape of Storms. Now, there's another, less famous danger zone too, Cape Corrientes in Mozambique. Portuguese sailors dreaded it in the 1500s and called it a ship-eating monster. Its name literally means Cape of Currents, because the water there rushes with insane force, strong enough to throw ships off course and onto the shore. Historians estimate that up to 30% of Portuguese ships sailing the India route were lost there. So even before they reached the Cape of Good Hope, they could already be sinking. Now, let's not forget the economics. Sailing around Africa wasn't just risky, it was expensive. More days at sea meant more food, more water, and more exhausted crews. Losing ships to storms was costing millions of dollars in today's money. Insurance companies dreaded covering voyages around the Cape because the odds of having to pay out a claim were so bad. When the Suez Canal opened, it wasn't just about saving time, it was about cutting the cost of disasters. Even today, with modern radar, weather forecasts, and GPS, rounding the Cape isn't a walk in the park. Of course not, it's water. Anyways, cargo ships that try to avoid canal fees or blockages, like the infamous traffic jam in 2021, still face monster waves and storms. Technology can predict the weather, but it can't stop the ocean from throwing a tantrum. Every captain who rounds the Cape today still knows they're passing through one of the most dangerous maritime zones on Earth. Yet another zone most ship captains choose to avoid is the roaring 40s and furious 50s in the Southern Ocean. That's between 40 and 50 degrees south latitude. Unlike the Northern Hemisphere, where continents break the flow, down here there's nothing but ocean. It's an endless highway for storms with no speed limit. Sailors gave this zone its dramatic nickname because when you're here, the wind doesn't whisper, it screams. Scientists have confirmed that these roaring winds can hit speeds up to 125 miles per hour. And screaming winds mean screaming seas. Waves in the roaring 40s can reach heights that make skyscrapers jealous, smashing against ship hulls with the force of a battering ram. Historically, clipper ships braved these waters to shave time off their voyages between Europe and Asia, but they paid the price with torn sails, broken masts, and sometimes entire crews swallowed whole by the sea. Even today, modern vessels avoid the 40s unless they have no choice. There are safer paths, routes that might take longer but aren't this risky. The 40s and 50s sure sound scary, but wait until the ocean tightens its grip in the Drake Passage. This narrow strip of water between Cape Horn and Antarctica is the gladiator arena of the seas. The entire Pacific Ocean is trying to squeeze through a gap only 500 miles wide and collides head-on with the Atlantic. Add the Southern Ocean currents, among the strongest on Earth, and you've got a recipe for chaos. The Drake doesn't just throw waves at you, it throws walls of water up to 50 feet high. Ships here don't ride the ocean, they cling to survival, like toys tossed in a washing machine on the highest spin cycle. The reason it's so brutal is pure physics. With no landmasses in the Southern Ocean to slow down wind or current, the Antarctic circumpolar current races around the globe. When it slams through the narrow funnel of the Drake, it accelerates like a jet engine. Storms roll in uninvited, and icebergs drift lazily into shipping lanes, ready to take a ship down any moment. Even experienced sailors describe the Drake as unpredictable. It's calm one moment, chaos the next. Historians note that before the Panama Canal opened in 1914, every ship heading from the Atlantic to the Pacific had to pass through here, and countless ones never made it. Today, cruise liners and research ships still brave the passage to reach Antarctica, but with enough seasickness bags to remind passengers that they're not on a pleasure cruise. They're crossing one of the most dangerous ocean stretches on the planet. You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar, It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light years wide. For comparison, just 1 light year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around -63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell, sandwiched between the moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell, which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system.